Okay. All right. Gurkan is here. Shazib is here, which is a good sight. So now we're going to go to the next sort of question. It comes from paper 2. Let's have a look. So in this sort of question, it says that a wave of amplitude 2 meter has intensity I. Now it says the intensity is reduced to half I. Draw the new wave. So they've given the old wave already. So let me just show you that. Looks like this. It's the amplitude. That would be the time, and they have given you a wave just like this. All right. They have written 2 meters here, and that's the intensity of the wave. Is it clear, everyone?
Yes.
Anyway, so this is the displacement. Sorry. Now what you're going to do is you guys need to draw the new wave. So we know that the first wave, I1, has an intensity of I, and the amplitude one is 2 meters. We do not know what would be the amplitude of second wave because the first wave is half I. Now I told you about the relationship. The relationship between these is that I1 over I2 will be equal to A1 squared over A2 squared, like that. Which basically means I1 will be I2 will be half I, A1 is 2 whole squared, and we want to find what would be A2 this way. So I and I will cancel out, 2 will go up, so it will be 2 equals to 4 squared over A2 squared. A2 squared is going to go there, 4 squared, sorry, I wrote 4, it should be just 4. So 4 upon 2, and then when we take under root on both sides, it's gonna be like this. Now, if you find the value of under root 2, it's gonna be 1.4 meters. Is it clear, everyone?
Yes.
So that means now the new amplitude is going to be 1.4 meters, and you got to draw the wave like this. Then you don't have to change the frequency or anything, just need to draw the new wave like that with the correct amplitude. All right, please write this down. If you have any questions, do let me know as well. Okay. Done, kids? Should I go forward now?
Yes.
Good. Now, sometimes what happens is that there are two factors which are changing. So we're going to learn that as well. So I'm going to go there now. Another type of question, which is this was type 2, by the way, so you can write type 2. And now we're going to look at type 3, this one. So in type 3 question, it says a wave has an amplitude A and frequency F. A new wave doubles the frequency and quarter the amplitude is generated. Calculate the new intensity in terms of I. That's the question. That's very simple. Let me just tell you about this one. That we have the first wave, I1, which has intensity I, amplitude A1 is A, frequency 1 is F. Then we have another wave, I2, which we want to find. A2 is a quarter of A, and the frequency F2 is 2 times the frequency of the previous wave, like that. When you've this done, then you guys need to realize something very important, and that is that we need to understand that I1 over I2 is basically A1 square over A2 square. You know that? And we also know that I1 over I2 is equal to frequency 1 square over frequency 2 square, because there are two factors now changing. So we're going to sort of combine them. And the is by simply writing I1 and I2, because I1 is directly proportional to A1 and I1 is also directly proportional to F1, so we can combine them like this: A1 squared F1 squared divided by A2 squared F2 squared. If somebody who doesn't understand this, please have a look at it very carefully. Shahzeb, Furqan, everything is clear?
Yes.
Alright. Abdullah, what about you? Zirwa? Afan? Okay. Very good. So now let's put in the values that we already have. What do we have? I1 is supposed to be I. I2 is what we need to find. A1 is A squared and F1 is F squared divided by A2 is 1 by 4 A squared, and F2 is basically F2 is basically 2F whole square. That's it, everyone.
Yes.
Okay. Once you have that, then try to simplify it. So we're going to simplify it. This is going to be A squared. This is going to be F squared divided by square of a quarter is 1 upon 16. a square, and then multiplied by 2 square is 4f square, like that. Now, a, f will cancel out with each other, so it's going to be basically this a cancels out with this square cancels out. And 4 basically cancels out with 4 here, so it's going to be 4. Which means now we're only left with 1 over 1 upon 4. 4 will go on top. So now we have I over I2 as this form, which I2 is going to be I upon 4. You guys get it? Please let me know. There's something that troubles you.
Yes.
Brother, you
But sir, you're lagging a little bit.
right, should not be like that. Connected to a very different internet. Is it okay now? Yes. Dania, is that okay?
Yes.
Okay. All right. Brother, you didn't join the class on, I don't know. You joined the last class as well, right, brother?
So I've taken one AS class and one A2 class last week.
And you decided to join now?
Yes, sir.
You have decided to join now as a regular student?
Yes, sir. I will talk with Sir Abu Bakr.
Okay, good. All right. Everything is clear, everyone? Please look at it and try to absorb
Yes.
this. If there's any point that you still feel it's difficult, let me know. Okay then. Now, the last question I'm going to give you as a test, if you guys can, solve and get me an answer. So this would be the question that you guys need to do. So in this question, it says a wave of amplitude 20 millimeter has intensity Ix. Another wave of same frequency but amplitude of 5 millimeter has intensity Iy. What is the ratio of Ix over Iy? Can you guys please try and find the answer to this? I think you guys will be able to do it in less than a minute.
So I got 16 is to 1 or 16 divided by 1.
Ratio 16. That is absolutely correct. Very good. All right. Anybody else who got it wrong or got the same answer? Please let me know. Okay. Yes, Raza, Shazib, Furkan, hurry up please. Zirwa, Dania, Asma,
Done,
Anand,
sir.
Usman,
I
Abdul.
got 16.
You got 16 as well? Very good. Others, please quickly do it. Good, Furkan, that's very good. Just waiting on Shazib, Zirwa, Raza, Asma, and Abdullah to drop upon. 16, very good, Zirwa. Nice. Quickly, others, do it, do it. No, Raza. It means, Raza, you haven't taken the square on the amplitude. I1 over I2 equals to A1 over A2 square. Can you check again, Raza, please? Something you did wrong there? Very good, Shazib. Good, Raza, correct. Asma, what about you? Alright. So, then, all you need to do is Ix over Iy equals to Ax squared over Ay squared. So, Ax is 20 whole squared divided by 5 whole squared. You should get 16 out of it. And that's this simple. Very good, Asma. Excellent job. All right, then. So, this concludes the intensity part of our lecture, which means we are pretty much going at a good speed. And now we're gonna start with something very, very new. So the next concept that I'm going to teach you, huh? कौन? हाँ वो आ जाएगा ठीक है हमारी. Wait a second, please. All right, kids, should I go forward now? All right, so now we're going to do a very, very important topic. It's called basically Doppler's effect. Now, basically, I believe waves in AS are the easiest, and there will be a short question of waves in any exam, which means you can score full. And the reason is that you just need to remember the Doppler effect definition. You need to remember that. So let's write that first. It's basically the apparent change in frequency observed by a stationary observer when a source of wave, a source of wave is moving relative to the observer. Now this definition will come for 2 marks. There are 2 keywords in this, but I also believe there is one more, and we want to basically keep that always, in mind. For example, so now let's highlight what exactly would be the thing. So the apparent change here is the first keyword, and relative to the observer is the second keyword. But I also believe that it is very essential to write stationary observer, because this is the only case in our syllabus. There are other cases as well in real world that we don't want to discuss in our scope of exam. All right. So make sure that you write these 3 words in the statement. Otherwise, your statement would not be considered correct. Now, what do we mean by Doppler's effect? So, Doppler's effect is a popular, very popular phenomena. If you've ever watched this series, it's called Big Bang Theory. You can find it on Netflix. They have a full episode on this as well. Anyway,
So it's
considering.
part of space physics, right?
Sorry?
It's part of space physics, right?
No, not only space. It's a real world. It's a present world phenomena as well. Like in our world, it works with sound and stuff as well.
So
All right. So let's have a look. So suppose you have a source like that, and the source is producing a wave, because the wave is produced like everywhere. So it's producing sound wave currently, and these are circular, like they're going in every direction. All right. So there's one person who's standing right here. Let's call him observer 1. And then there's another person who's standing right here. Let's call him observer 2. Is it clear?
Yes.
Now, if we consider that these 2 people are stationary, also this is stationary, which means not moving, which means the wavelength that is observed by this observer is equal to the wavelength observed by this observer. Do you guys agree with that?
Yes.
They're the same distance apart, and they're also basically the source is stationary. But what happens is that if you basically the source starts to move, now this is a source, and now the source starts to move in one direction like that. So when it basically produces a wave, it has already moved towards the right side, so it becomes closer to the wave that it has produced and away from the wave that is going behind it. And slowly what happens is you tend to see a sort of movement or wave pattern like this. Okay. What happens is that then the observer that was right in front of this, where it was moving, and the observer that was basically behind it hear different frequency waves. Why? Because if you notice from the diagram, the wavelength here is shorter, whereas the wavelength that this person is gonna observe is longer. Do you guys understand that?
Yes.
So this person towards whom this source is moving is going to hear or observe a high frequency wave, and this is an apparent change, whereas this person is going to hear or observe a low frequency wave. Do you guys understand that?
Yes.
All right, you guys can draw this, and then I'm going to give you some real world examples. You might have already observed this phenomena a lot of times, specifically when an ambulance passes by you. When the ambulance is approaching you, you would hear a shriller sound, high frequency, and when it has passed, it's going away from you. Then you hear a graver sound because it's a change in frequency that you observe. Is it clear? Now I don't know that whether you have seen those race car videos. All right, so you can write this down, then I'll show you. All right, kids. So this is pretty good. Now I just want to show you a very interesting thing. If you go on, you don't have to go anywhere. Let's write Doppler's effect in race cars. Okay, so you can actually check this video on your own as well. It's okay. I don't know if you can hear the sound. I'm not sure about that, but it should look like something like this. Oh, you cannot. Oh, you cannot hear the sound. My bad. The thing is that when the cars pass, I think this will show you something. I hope it does. Or you can check it out. Okay, like, oh, I'm going to pause this. Wait. Pause, pause, pause. Oh my God. Okay. If you see, if there was an observer right here, right? So you see how close the waves are. So the person right in front of this car is going to hear a shriller sound, high frequency one, and the person who's right behind this car would hear a graver sound. Do you guys understand that? Yes, yes, exactly,
Yes.
Raza. You guys can check this out once because iPad doesn't allow me to share the sound with you.
Sir, I could hear it.
You can hear?
Yes.
Okay, then that's good. I cannot hear that. Chalo. So when it's going like it's coming towards you, you see a shriller sound, and as they pass, it's make boom boom sound like that. So it's basically
What is it? Shriller?
shriller means high frequency sound. You get it? That's why in
And
A2 when
what's
you
the other
learn,
one?
come again, Himal.
Shriller and what's the other one?
Graver. Graver
Okay.
means low frequency. Now, when you learn in A2 about cosmology, the space physics, You'll also be surprised that Doppler's effect is used to determine the age of universe and how far is something going relative to us, or how fast the world is, the universe expanding and stuff like that. So it's pretty interesting. But for now, most questions would be regarding sound, which is all right. But then we are gonna basically now segregate into two parts. So let's look at that. So first of all, we're gonna give a heading. We're gonna write source is moving away. All right. When this happens, so what do you experience? So first of all, what you experience is that observed frequency is lower than actual frequency. The other thing is observed wavelength is higher than actual wavelength. Is it clear, everyone? Because wavelength and frequency are inversely proportional, that's why. Now, when the source is moving towards the observer, so what do you do then? What do you experience is that observed frequency is higher than actual frequency, and observed wavelength is lower than actual wavelength. Is it clear, everyone?
Yes.
Now, the best thing that you would really like this, and that is the formula for this is already given in the exam. The formulas in the data sheet will be given like this: F naught equals to Fs times V over V plus minus Vs. So this is the formula for Doppler's effect. It's already given.
So will it be given in 2025 too?
Sorry?
Will it be given in 2025 too?
Yes, it will be given. But there's a catch to it. It is given, but then when something is moving away from the observer, you would want to use F naught equals to Fs times V over V plus Vs. So you need to remember this. So you add the velocities at the bottom when it's moving away, and you use the same formula, but now when it's moving towards the observer, it will be Fs. By the way, Fs is just this subscript, by the way. So V minus Vs. That's why there's a plus minus sign. So you have to decide which formula you will use according to the situation. That's what you have to do, but the formula is given. Is it clear?
Yes.
So, but what is FS?
Yes, I'm gonna basically write all these terms. So in this one, F naught is called the observed frequency. V is basically the speed of the wave. Whatever the wave is, if it's light, you got to put the speed of light. If it's sound, you got to put the speed of sound. Vs is the speed of source, and F is the frequency of actual wave. Do you guys understand that? Or source?
Yes.
So what's the difference between B and VS?
What's the difference between what?
V and Vs. Because the wave is formed
Means
by the
that,
sound.
let's suppose there's a car. All right, there's a car. Now there's an ambulance that is sounding an alarm. So basically, the speed of source or speed of wave would be, let's suppose, 300 meters per second. That is the speed of sound. But the car speed can be like 20, 30, whatever. Do you understand? Like that.
Okay.
Like that. So the questions about this is so easy, and the hardest question I've ever seen in any exam up till now. I'm just gonna write it down first. You guys just copy this down, and we'll see. Okay. All right. So first, I'm gonna give you the question so you guys can attempt it, and then we're gonna go forward. Okay. So in this example, it says warning signal of an ambulance has a frequency of 600 hertz. Okay. Now, speed of sound in air is 330 meters per second. The ambulance is traveling with a constant velocity of 25 meters per second towards the observer. All right, they've shown an observer here. They have shown ambulance. Okay. And the ambulance basically goes like this. This is the initial position, and this is the final position. Now they say calculate the change in frequency observed between initial and final position. So you got to find the change of frequency between initial and final. Can you guys try this, please? Just to give you a hint, this is obviously the original frequency. This has to be f. This is the speed of sound. This has to be v. This is the speed of source, which is vs. So he will observe a frequency f naught when he's going here. He will observe another f naught when it's going away. You have to find the change between them. So that is what you need. Okay. Try this, please.
Sir, I got -1 divided by
-1?
no, negative 111.
You can't get negative. You have to do bigger minus smaller.
Okay, then it is positive.
Positive what?
111.
111. That is incorrect. Not the correct answer. What equation did you use in the first position? Can you tell me that, please?
Fs into V divided by V minus Vs.
Okay, fine. What is Fs?
600,
Into
330,
divided by?
300 plus, I mean minus 25.
No, 330 minus 25. Where did you
Oh,
get 3?
that was a mistake. It's 91.
91. That is correct. Mhm.
Yes, sir, got the same answer.
Yes, very good. Anyone else who got the answer? 91. Furkan, Shazib, Zirwa, Raza, Abdullah, Asma, Tania.
Yes.
Done. Okay. Alright, guys, please try this so that your concept is cleared. What to put where, and then it will be all good. All right, kids. You guys done? Everybody got 91? Very good.
Yes.
So, So it's going to be just like for the first position, because it's moving towards, we're going to write F naught equals to Fs times V minus Vs. For the final position, we're going to write F naught equals to Fs times V plus Vs. So which means that this is, Fs is going to be, I think, what was it? 600 times 330 divided by 330 minus 25. This is going to be 600 times 330 divided by 330 plus 25. You should get about 649 hertz for this one. You should get 558 hertz from this one. When you find the change in frequency, it should give you 91. All right, so I hope you guys understand this, and there won't be any other question more difficult than this. Usually they will ask you just for one position. If they give you change, that's very simple. All right, so I will see you now in tomorrow's class.
Thank you, sir.
And let's see. Okay, bye. Have a nice day.
Bye-bye.
Thank you, sir.